Today we're going to be solving the equation 9 to the power of sine squared x plus 9 to the power of cos squared x equals 6. And we're only looking for solutions within the domain 0 and pi over 2. First, let's use the trig identity of sine squared x plus cos squared x equals 1. Using the identity, we can isolate cos squared x by itself by subtracting both sides by sine squared x. The end result is cos squared x equals 1 minus sine squared x. We can now plug this in back for this exponent, and we get 9 to the power of sine squared x plus 9 to the power of 1 minus sine squared x equals 6. If we take a closer look at the second term here, we can simplify it a little bit further. We can simplify 9 to the power of 1 minus sine squared x into 9 over 9 to the power of sine squared x. Let's plug that back in. And so now, what we have here is 9 to the power of sine squared x plus 9 over 9 to the power of sine squared x equals 6. Now, to make this look a little simpler for our eyes, let's set y equal to 9 to the power of sine squared x. And let's plug that in. So we get y plus 9 over y equals 6. Let's remove the fraction on the bottom here by multiplying both sides by y. And we get y squared plus 9 equals 6y. And if you look closely, this looks like a quadratic. And so let's solve for this quadratic. Let's put the 6y on the left. So subtract 6y from both sides, and we get y squared minus 6y plus 9 equals 0. From here, we can factor this expression into y minus 3 squared. And the other side stays 0. And using the 0 method, y must equal 3. Now let's go back to our substitution, where we said that y equals 9 to the power of sine squared x. Let's plug that back in, and we get 9 to the power of sine squared x equals 3. Remember that 9 is equal to 3 squared, so we can plug it back in, and we get 3 squared to the power of sine squared x equals 3. And using the exponential laws, we can multiply these two exponents here, and we get 3 to the power of 2 sine squared x equals 3. Since the bases are the same, the exponents must be the same, and this is an invisible 1 here. So therefore, 2 sine squared x equals 1. And from here, we'll divide both sides by 2, and we get sine squared x equals 1 over 2. Let's get rid of the squared there. So we will square root both sides, giving us sine x equals root 1 over 2. Finally, the last step is to use the inverse sine function. And let's plug that into our calculator here. And our x is pi over 4. And let's check if this is in our domain stated above, which is between 0 and pi over 4, inclusive. So this does fit in our domain. So there's our answer.